The calculations of ANOVA. ANOVA is used when we want to test the null hypothesis that three or more population means are equal to each other against the alternative hypothesis that at least one mean is different. Conceptually, we do this by measuring how far away the sample means of each group are from each other and rejecting the null if this distance is considered too far away to be due to random chance and variation. This test is done by looking at two types of variation. One, the variation between groups, and two, the variation within groups. First, variation between groups measures the difference between the sample means of the groups. It sums up the squared difference of each sample mean to the so-called grand mean of all the observations in all the groups, giving more weight to larger samples. This total is called the sum of squares between, or the sum of squares treatment. Next, we get the average variation between groups by taking the sum of squares between and dividing by the degrees of freedom, which is r minus 1, where r is the number of groups. Thus, the mean square between gives the average variation between the groups. On the other hand, variation within groups measures variation that occurs naturally within groups, like a standard deviation. Each observation is compared to its own group's mean. The total squared distance of all the points in all the samples to their own mean is called the sum of squares within, or sum of squares error. We find then the average variation within groups by dividing the sum of squares error by its degrees of freedom, which is n, the total number of observations in all groups, minus r, the number of groups. This is called the mean square error. We now consider how much larger the average variation between groups is compared to the average variation within groups. The test is done with what is called an F statistic, which is a ratio of the mean square between to the mean square error. These calculations can be done with statistical software, online calculators, or even Excel, and will output an ANOVA table showing the F statistic and its p-value. If the F statistic is large, it means there is a relatively large difference between groups, considering the variation within groups, that is probably not due to random variation. In this case, we will reject the null that all means are equal and conclude that the population means are probably not all equal. If the F statistic is not too large, we conclude that any difference in the sample means could have been due to sampling error, and we do not reject the null that all the population means are equal. The F statistic follows an F distribution with r minus 1 and n minus r degrees of freedom, so we can determine if the F statistic is too large by either comparing the F statistic to a critical value associated with the significance level and rejecting the null if the F statistic is larger than the critical value, or by comparing the p-value for the F statistic to the significance level and rejecting the null if the p-value is less than alpha. Assuming the null is not rejected, no further analysis is needed. However, if the null is rejected, meaning that we have found evidence to suggest that at least one population mean is different, we then conduct what are called post hoc tests to determine exactly which means are larger or smaller than which others and to estimate those differences. There are multiple post hoc tests to compare each pair of population means, that is, mu1 versus mu2, mu1 versus mu3, mu2 versus mu3, etc. Post hoc tests can be done using either confidence intervals or hypothesis tests, and different software packages use different methods. Please note, while Excel will provide an ANOVA table with an F statistic and p-value, it will not provide any post hoc tests. If the software outputs confidence intervals for differences in each pair of means, then each confidence interval can be interpreted as follows. If the confidence interval for mu A minus mu B consists of all positive values, it means we are confident that mu A minus mu B is positive, which means mu A is probably greater than mu B. The values of the confidence interval estimate how large the difference is. For example, if the confidence interval for mu A minus mu B goes from 10 to 20, then we estimate that mu A is greater than mu B by about 10 to 20 units. On the other hand, if the confidence interval for mu A minus mu B consists completely of negative values, it means we are confident that mu A minus mu B is negative, which means mu A is less than mu B. Again, the values of the confidence interval estimate how large the difference is. For example, if the confidence interval for mu A minus mu B goes from -8 to -5, then we estimate that mu A is less than mu B by about 5 to 8 units. The final possibility is that the confidence interval for mu A minus mu B includes 0. That is, it goes from a negative to a positive number. This output implies that we are not sure if mu A minus mu B is positive or negative, or in other words, we don't have evidence that either mean is larger than the other. In this case, we say that the two means could be equal to each other, and we don't estimate any difference since we are not sure one exists. Other softwares show results for a hypothesis test for each pair of means. In this case, the calculation takes into account how large the samples are and how much variation is in the groups, and provides a critical value for the test to compare mu A to mu B. The null is that these two population means are equal, and if the difference between the sample means of these two groups is larger than the critical value, we conclude this difference is too large to be due to sampling error, and therefore say these two population means are probably different. This software output is often shown as an estimated difference between the two sample means and a p-value, though sometimes the critical value itself is not shown. One would know that the difference between two particular means is significant if the p-value is smaller than the significance level, and then the difference in the population means could be estimated by the difference in the sample means.